Niels Bohr 1913 paper, a groundbreaking paper. That paper laid the foundation of quantum mechanics, right? That atomic theory, the paper on atomic theory and the energy level and the photon, all the ideas came from Max Planck and Albert Einstein, photoelectric effect, and he put them together and he discussed the idea why electron jump, right, from the ground state N1 to N2 to N3, right, and jump down from the excited state to the lower state to from N3 to N2 and so on. All right, let's discuss that. Okay, so where can we start? We can start from, I don't know, hydrogen atom. If you go to the hydrogen atom, right, this is the Bohr model of hydrogen atom. What is missing? Electron, of course, right? And of course, this is just one shell. We can draw many shells. This is, by the way, 2D version of a Bohr model for hydrogen atom. What are you thinking is, where is the proton? All right, the Bohr model of hydrogen atom do not need proton because there is no repulsive force in the nucleus. If it was helium, then of course there is a repulsive force in the nucleus, right? So you need a proton. In this case, you don't need proton because there is no repulsive force in the nucleus. The proton make it stable when there is a repulsive force. All right, this is electrostatic force. Repulsive electrostatic force comes from Coulomb's law. Okay, good. So there is no repulsive force over here. Why is that? Just because one proton. So now this is N, and this is second shell. This is, let's say, third shell. This is, let's say, fourth shell. Now electron is here. When electron is here, we call N1. When the electron is there, we call N2. When the electron is here, we call N3. And the electron is here, N4. When the electron is here, we can call N5, but we don't have time. So we're going to just call N infinity. So what does that mean? This one is R1, radius 1. This one is R2, radius 2. This one is R3, radius 3. And this one is R4, radius 4. And of course, this one, what are you thinking? This one is R infinity. All right, when you have N1, you have E1. At N2, you have E2. At N3, you have E3. At N4, you have E4. And at N infinity, you have infinity, which is 0, which we'll explain in a second why at E infinity is 0. Now let's convert this one to 1D. If we do convert the Bohr model, this is called Bohr model for hydrogen, of course. Then what do you see? You see this N1, E1, you see N2, E2, you see N3, E3, you see N4, E4, you see N infinity, E infinity. Of course, I did not draw it to the scale. Okay, now you're probably thinking, what is energy? The energy applied by who? By the nucleus. To be more specific, proton on electron. So the proton telling electron, hey, you cannot go, you cannot escape. But electron want to escape. Why is that? Because when electron absorbs some energy, right, it has to absorb the allowed amount of energy. And that is how much? When electron if electron is here, if it absorbs this much energy, which is, let's see, let's call it HCR over n square, n final square, minus HCR over n initial square. All right, this much energy, okay, then it can move up. So it's quantized, and that's all we're going to try to understand. What is this formula name? This formula name is Bohr-Rydberg formula. So let's use the Bohr-Rydberg formula to find the energy at N1. When electron goes to N2, nucleus doesn't like it, proton doesn't like it, because proton knows that the proton doesn't have good control on electron because it is at n2. When it goes to n3, the proton doesn't like it. When it goes to n4, proton doesn't like it because from n4 to n infinity, it doesn't take that much energy. When electron is at n infinity, right? That means electron escape the hydrogen atom. When electron escape the hydrogen atom or at a radius infinite distance away from the nucleus, that means that hydrogen atom became hydrogen ion. It doesn't have the electron anymore. It became from atom to negatively charged. All right. So now let's see the E. So what is E? E is, this is the Rydberg-Bohr formula. Negative HCr, okay, over n square. So H is the Planck constant, which is 6.63 times 10 raised to negative 34 joule per second. C is the speed of light, which is uh, 3 times 10 raised to 8 meter per second. I'm going to erase this, so I need room. R is Rydberg constant, which is 1.097 times 10 raised to 7 1 over meter. All right, so divide by n square. N is only allowed state. N is quantized. What does that mean? N has to be either 1D, or 2, or 3, or 4, or 5. It cannot be 1.2, or it cannot be 1.3. So electron, if it won, it cannot go between N1 and N2. It has to either go to N2, or N3, or N4, and so on. So this what gave birth to quantum mechanics. What does that mean? The electron only allowed to go the quantized state, not any location it does want to. All right, so we know what is n. N can be 1, 2, 3, 4. Okay, so n is a whole number. Very nice. Good. So this is negative 2.18 times 10 raised to 18, negative 18 joule. Of course, over n squared. Don't forget that. Now we're going to convert this one to electron volt because the energy we describe at electron volt. Electron volt relation to joule is like the meter relation to centimeter. When I say 1 meter, if you say 100 centimeters, who is right? Both. When I say 1 joule, and if you say, let's find out 1 joule is how much electron volt, then we can make that. All right, let's see. Okay, good. So now, if you have a negative plate, right, and if you have a positive plate, and the potential difference between these two is 0 volt and 1 volt, and if you have a negative charge over here, the kinetic energy for negative charge required to move from negative terminal to positive terminal is by definition what we call electron volt. So then what is electron volt? Electron volt is QV. All right, so electron volt is, Q is the charge, 1.6 times 10 raised to negative 19 coulomb. And by definition, 1 volt, and so this is 1 volt potential difference. So 1 volt, right, so that's what 1 electron volt is. All right, now we're going to convert this one to electron volt. So you have a negative 2.18 times 10 raised to negative 18 joule times what do you just discover? You just discover 1 electron volt and joule. What is the relationship? 1 electron volt is 1.6 times 10 raised to negative 19. Joule cancel. So that what means? That means negative 2.18 times 10 raised to negative 18 joule is equal to how much electron volt? Negative 13.6 electron volt. They are the same statement. Okay, very nice. Okay, so we are making progress. So this one then, how much negative 13.6 electron volt. Then this one would be how much? You can say negative 13.6 divided by 2 square. Maybe let's see the calculator. Negative 13.6 divided by 4 would be negative 3.4. This is a small chalk. I'm running out of chalk. So this is negative 3.4 electron volt. 3 square, 13.6 divided by 9, 1.5. 4 square divided by 16.85. And you know what happened when you divide it by big number is 0. Okay, now if you are electron, if you are at n equal to 1 and you jump up to n equal to, how much energy you have to absorb? Okay, let's see how much energy you have to absorb. You have to absorb, this is the equation. You only can jump up if you can absorb a right amount of energy. And how much is the right amount if you want to jump to n2? So that would be E2 minus E1. Okay. Or we can say absolute value of E1 minus absolute value of E2. What is E1? Absolute value of E1, 13.6 electron volt. What is absolute value of E2? 3.4 electron volt. So this is 10.2 electron volt. If you can absorb, if you are an electron, you absorb 13.2 electron volt, you can jump up from N1 to N2, and so on. However, in order to make the hydrogen an ion, hydrogen atom to hydrogen ion, then how much energy you have to absorb? Exactly 13.6, but positive. If you do absorb positive 13.6, that hydrogen atom become hydrogen ion. All right, now we're going to try to understand how light being created from this, okay? Because this has to do with something that is very important, how light being created. Because you see, we human got inspiration from these, from the stars, to create light, right? To light up houses around the world. How did you do that? 1800. Two ways we have been doing it. By creating batteries, two ways. 1800, Alessandro Volta created battery by creating potential difference between anode and cathode, between a terminal made of zinc and terminal made of copper. The zinc has smaller need for electron and copper has a bigger need for electron. So as soon as you connected them by a wire, the electron going to move from zinc to copper, making a potential difference. Zinc will become positive, copper become negative. Potential difference is voltage. There you go. You can get the voltage. Voltage kicks the charges. When charges moves, what we call it current, but current is not quite light. So what is light? The light is when the electric energy, all right, convert to heat energy. And when heat energy goes to like a tungsten in a light bulb, if heat increases, the tungsten of a light bulb glows up. So there you go. LED works a little differently, but the idea is same. Okay, now there are other ways we human have been creating light up bulbs around the world, and that is by creating EMF. EMF is induced voltage. How do you create EMF? By creating a magnetic field. How do you create magnetic field? Two ways. One way is we learn it from Thales, 600 BC, long time ago. Put a magnet, it creates the magnetic field around. Very simple. Other way we create magnetic field we learn it from Hans Ørsted, right? How we do that? A wire that carries current, it creates magnetic field around it. 1820, you discovered Hans Ørsted in Denmark. He discovered. Faraday took that idea, and he took that idea, and moving magnet, right, can create the electric field, and electric field can create magnetic field. Moving charge can create magnetic field and electric field at the same time. So how can you create the voltage, EMF? Not like the way Volta did. You're gonna do it by moving a magnet in and out of a coil made of a wire, right? That's how you can create EMF. EMF is induced voltage. Induced voltage can create induced current, and induced current can same way, uh, that electric energy can convert to heat energy, and heat energy can, if you increase the heat, it glow what? Tungsten of a light bulb, so you light up the entire city. Good. That's how we have been doing it. Now, how does God do it? The God doesn't do it the same way. The God does it different way. Let's see how. If you are an electron and you jump down from upper level, so say N4 to N2, then electron release what? Electron release energy. All right. In terms of a packet, energy, it releases energy, which we call HF, discovered by Max Planck, 1900, right? Which is a bag of packet. Einstein called it photon. Einstein, 1905 paper, he called it photon. Photon is a bag of packet, HF. Einstein gave the idea of photon by photoelectric effect, which he won the Nobel Prize for. Okay. Now, so it emits energy, which we human perceive that as light. Now, if you are an electron, you jump from N4 to N2, what type of light you emit? Again, we're going to use the Bohr. The Bohr wrote the paper 1913, atomic theory, on atomic theory, how atoms jump up and jump down. He won the Nobel Prize in less than 10 years, 1922. He won the Nobel Prize, and Einstein also won the Nobel Prize for same idea. So Einstein won the Nobel Prize for building the foundation of quantum mechanics. Bohr also won the Nobel Prize for building the foundation of quantum mechanics, and both won the Nobel Prize for helping us understand this very simple idea. Okay, let's go. So now, N4 to N2, how do you do that? So now you write energy is equal to, you're going to write H CR, of course, negative, 1 over N final square minus 1 over N initial square. Now, this one we already calculated, negative 2.18 times 10 raised to negative 18 joule. 1 over F square, so this is you're going to call initial, this is you're going to call final. So this one is 1 over 16. This one is 1 over 4, right? So N final is 1 over 4. This is final, 1 over 4. This is N initial, 1 over 16. So E is equal to 2.18. We take the absolute value times 10 raised to, I'm running out of chalk, 3 over 16. So this is going to give you, I believe, I don't know, let me check, 2.18. 3 divided by 16, and let's give you this, times 2.18, and that gives you 4. Okay, so this gives you 4 times 10 raised to negative 19 joule. You're going to convert this one by using Planck constant, Planck hypothesis. H is equal to energy is equal to HF. So F is equal to E over H. So E is 4 times 10 raised to negative 19 joule, and H is Planck constant, 6.63 times 10 raised to negative 3. So F is equal to what? 6 times 10 raised to 14 hertz. And Balmer series said if it is 6.10 raised to 14 hertz, it is in the region of blue and green. So we human perceive it as either blue or green by using Balmer. Who invented the Balmer series, and using the same equation, lambda is equal to, this is B This is n. This is n minus m. So what is b? B is 364. This is Balmer equation. N is 16, and 16 minus 4 is 12. And this is also close to 4 or 500 nanometers. So 400 and 500 nanometer, 500 nanometer is in the region of blue and green. So I'm going to stop here because look, my size of my chalk, I don't even see it. Okay, so the main idea is the two people who lay the foundation of three people actually lay the foundation of quantum mechanics: Max Planck by HF, the Niels Bohr by the equation which is HCR over n squared, and Albert Einstein by photoelectric effect. And that three guy also won the Nobel Prize for founding the quantum mechanics, a different branch of physics.